Okay, hello, welcome back. Thanks for the presentation speakers, and if I could be joined once again by our live speakers in Vancouver and London and Bangalore. Thank you, Joeri, Kirsten and Bala for joining us once again. So I understand some of the slides may have been a bit blurry at times for some of the viewers, so have no fear, all the presentations and the slide decks will be available on the website. My colleagues will share it in the chat link here, and you can always contact us directly afterwards if you can't find them. They'll be on the C2GLearn. Just follow to the page of the IPCC related content, and you should be able to find it soon after this event from tomorrow onwards. Now, we're going to pivot to a Q&A session. We've got a tremendous resource here, three very experienced experts, and this is your opportunity to pose some questions to them to help clarify all our understanding, very complex issues. Also, we're dealing with two largely quite different in many respects areas here, so carbon dioxide removal and SRM, obviously very different, large uncertainties around them in many cases. So we'll try to distinguish between the two as we go through the questions. We've had one question already in the Q&A. Remember to press the Q&A button if you want to ask a question, and we'll take them from the top. Actually, we had the very first question was in the chat. Please don't put your questions in the chat. Try and put them in the Q&A so we don't lose them. And perhaps we'll start off with this first one for whoever'd like to take it from the panel. This is from Stephen Salter, who says that aiming for 1.5 degrees C implies that the present conditions are acceptable. So why do we not want to fund research on ways that might get us down to zero? Good question. More a political as well as a scientific question, perhaps. But who'd like to take that? Joeri, would you like to give that first go?
Yeah, happy to answer that question. And I think the research for answering that question is already being carried out and has already been assessed in the IPCC latest assessment report. I mean, we understand that from a geophysical perspective, if we achieve net negative CO2 emissions, we will be slowly reversing some of the warming. We won't be reversing all of the aspects of climate change, some aspects of sea level rise, some aspects of also in the carbon cycle might not be reversed on time scale of centuries to millennia or even never. But ultimately that research is ongoing. Why are we focusing on 1.5? Of course, that is because the countries, the joint countries of the UNFCCC have decided that that is the lowest limit in their international target. That ultimately is not a scientific question to be answering.
Quite right. Thanks, Joeri. I don't know whether Kirsten or Bala want to add to that, but I think that's a fairly succinct answer there. If I might pick up on something you mentioned there, Joeri, onto another question, this concept of net negative. Now, for some of our viewers that are not scientists that come from more the policy community, they will have heard a lot more about net zero. We've all heard net zero all over the place for the last year or so. The drum roll has been intensifying, particularly around the Glasgow COP at the end of last year. Can you tell us any more? Can any of you tell us more perhaps about what role does CDR or this carbon dioxide carbon removals have to play in reaching net zero? What exactly is the role? Is it even possible to get to net zero without CDR? And indeed, net negative, what's the relationship? Is there a way you could explain that fairly succinctly to some of our viewers that might be a little lost with what net zero means in terms of actually what might need to be done or what decisions might need to be addressed? Who'd like to take that?
I can also start off, and I'm happy to hear additions by Kirsten and Bala. We have to be clear about what is, first and foremost, why are we talking about net zero targets? And that is because we have now established that every ton of CO2, or scientifically established that every ton of CO2 that we add to the atmosphere adds to global warming. And that means that if we want to stop global warming from further increasing, we have to stop adding CO2 to the atmosphere. There are two ways of doing that. One is to stop emitting or just stop doing any interactions with CO2, stop emitting and stop removing it, and then there is no net effect on CO2, or we remove exactly the same amount as we would still be emitting. And that is where that net zero comes from. And although that is not really part of the research that is being assessed or the science that is being assessed in Working Group 1, the 1.5 degree special report of the IPCC, published 4 years ago, and showed, and I now showed also in my presentation, is that there are different strategies that can be pursued societally to reach that net zero goal. They all involve strong reductions in CO2 emissions, and somehow they all involve some degree of some sort of carbon dioxide removal. How much of it, which types, where and how, these are still kind of policy and societal questions to be answered. But scientifically, all scenarios, all pathways that are out there at least use some degree of carbon dioxide removal. In some cases, that is just from natural sources, and in many cases, it's also to some degree from technological sources, such as bioenergy with carbon capture and storage, or the direct air capture that Kirsten also referred to in her presentation.
Great, thanks, Joeri. Unless Kirsten or Bala want to add to that, I think let's move on to another question. This is from Fernando Tudela, and perhaps this is one for you, Kirsten. Don't you think there's been an overconfidence in relying on planting trees as a prevailing strategy in many developing countries for dealing with climate change? This perhaps speaks to some of the content of your presentation. Any thoughts on that?
Yeah, so the enthusiasm for planting trees, both in regions where there were no trees before, which we call afforestation, or replanting trees in areas where they have been removed, which we call reforestation, comes from the potential to sequester carbon dioxide through these methodologies. So research has shown that by 2030 we could remove around. So this is we could remove up to about 10 gigatons of carbon dioxide globally by planting trees. So this is so the question that is posed here is a very broad one, and I'll answer that from a Working Group 1 perspective, because many of the government's implications and also the regional implications are not addressed in our report, they're addressed in the Working Group 3 report. So what I can say about afforestation from a Working Group 1 perspective is that first of all, yes, trees do sequester carbon dioxide from the atmosphere, but they do also alter the surface energy balance. So they trees are generally darker than bare soil. So when we plant trees, we reduce the albedo of the Earth's surface, and so we reflect less incoming solar radiation, which could lead to local or regional warming. So in fact, research has shown that if we afforest or reforest at mid to high latitudes, we might get a net warming effect. So from a climate system perspective, there are certain regions where afforestation from a climate perspective is actually not very effective. Things change a little bit if we look at low latitudes. So especially in tropical regions, it has been shown that because the albedo effect is smaller, and also there's an increase in evaporation, that actually these effects compound the CO2 sequestration. And so this is why, at least from a climate science perspective, the tropical regions seem to be the better locations to actually look at tree planting in terms of climate effectiveness. Then obviously there are many government's implications on the ground that have to do with socioeconomic conditions in those countries, but those are actually not addressed in the Working Group 1 report. So just to summarize, when we talk about afforestation and reforestation, we should not only consider the CO2 sequestration potential, but we really need to take these other potential climate effects into account, which in some regions could counter the benefit of planting trees.
Great, thank you, Kirsten, for a helpful answer there. If I might tag on another question here, which was from Chris Vivian. It's more of a speculative question, but it's in the similar kind of vein. What if you removed CO2 from the ocean at the same time as from the atmosphere at a rate so as to maintain the equilibrium between them? Would this not reduce the rebound of CO2 back into the atmosphere from the ocean? That one of the mechanisms that you were referring to?
Yeah, that is correct. What is really driving the outgassing or the release of carbon dioxide from the ocean is the imbalance between the ocean and the atmosphere. So if there's more ocean, if there is more carbon in the ocean than there's in the atmosphere, then there would be a flux out of the ocean. So yes, it is correct that if we were to manage to remove carbon dioxide at the same rate from the atmosphere and the ocean and keep that gradient constant, then likely we wouldn't see that rebound. However, in effect, what is happening is that the ocean has its own time scales. So the ocean circulates, and those time scales, so depending on the processes that we're looking at, they vary from years to actually many centuries to millennia. And these time scales really influence the response of the ocean. So designing intervention in such a way that we could achieve the same rate of removal would be very tricky. And this is also because we have the land involved at the same time, right? So as we change the concentration in the atmosphere, the land will also respond to that. So to engineer the system in such a way to prevent rebound is very tricky because of these various timescales involved.
Thank you. Thanks very much. Now, if I might, there's a question here directed specifically to Joeri, and then I want to move on and address a question to Bala afterwards on moving on to the topic of solar radiation modification. But first, Joeri, a question from Ulrika Arnio. Ulrika, I hope I pronounced your name correctly. How are the non-CO2 now assumed to develop in the budget calculations, to decrease or increase? So what about permafrost melt and methane clathrates? I'm not sure what clathrate is, maybe you do. Are there impact included? So is the impact of this permafrost melt included in the budgets?
Yeah, so the short answer is yes. So the question refers to two types of emissions. One are the human caused emissions. So if we emit more methane in the future, then there is less space for emitting CO2. And that kind of trade-off is taken into account by assuming also equally strong reductions in methane that are consistent with the transformation to a net zero CO2 world. But there is variation. I highlighted that depending on how successful or unsuccessful we are in those reductions of those human-caused methane emissions and other greenhouse gas emissions, carbon budgets might be higher or lower by 220 billion tons of CO2 or more even. Yeah, might vary. Then the emissions that come from permafrost are also taken into account through a different term in our estimation. So again, to conclude, yes, those factors are taken into account as uncertainties in the budget calculations.
Thanks, Joeri. Anyone want to add to that? Or I think that covers it quite nicely. If not, let's move on to a question from Miles Perry. Miles asked, and perhaps this one for you, Bala, what are the major knowledge gaps in SRM? So, and also a question to all the panelists. What do panelists think of the argument that SRM is so inherently dangerous that there shouldn't even be research into the topic? So Bala, perhaps you'd like to start us with that one.
I don't know whether we could call this as a knowledge gap, but I would rather put it as uncertainty. First of all, the uncertainty in quantification of even at the global mean level, how much cooling, a certain amount of aerosol can cause. I think there is large uncertainty, which is mainly coming from, in the case of SAI, it comes from the aerosol microphysics, the stratosphere. But in the case of other two aerosol-based schemes, such as MCB and CCT, the aerosols actually interact with the clouds. And we all know that, this is not just for SRM, but even in the case of, projection of climate change, the aerosol cloud interaction, aerosol cloud and radiation interaction, provides one of the largest uncertainty. So mainly there is large uncertainty in this, but then, because of this, this uncertainty is in fact, much larger when you look at the regional scale as well as seasonal scale. And, and also you could actually have even, when you exactly compensate climate change at the global scale, that could be large regional and overcompensating effects at the regional scale. So, how much that is, I think that's where the biggest uncertainty is.
Great, thanks, Bala. And the second part of Miles's question to any of the panelists, what do you think of the argument that SRM is so inherently dangerous that there shouldn't even be research into the topic? Anyone like to respond on that? Or not strictly a science question, but perhaps it is. Yeah.
I'm happy to respond.
Sure.
Yeah. Yes, I do think that it is important to do research in it, and I think, and there are two reasons for that. First, just at face value, SRM sounds so simple and so simple and almost too good to be true. And it's only with the additional research that we have put into it that we understand the risks for the hydrological cycle, for regional and seasonal changes. So that research was really important to identify those risks, because otherwise it might have looked much more safer than what we now know it is. A second reason why we should be researching it is that SRM has this very particular characteristic that it can basically be deployed by a single large actor. It is not so expensive, and it doesn't really require global cooperation. And so really understanding those consequences from a scientific point of view are essential.
Thank you, Joeri. Kirsten or Bala, would you like to make a respond on that, or should we move on?
Yeah, maybe I can just very quickly add to that under the SRM umbrella, there are very different approaches as Bala showed, right? And there are these large-scale engineering approaches such as aerosol injection, modification of clouds, but then there's also more local interventions which have to do with changing the albedo of the Earth's surface through crop engineering or thinking about urban surfaces and so on. And I think so we also have to make a distinction between different types of approaches, and those that are more local are less risky to cause planetary unintended effects.
Thank you, Kirsten. Bala, what does I might ask a further question? Does the report address this relationship between SRM and these other climate responses, for example, CDR or emissions reduction and adaptation as well? Is there any? Does it address that relationship in any way?
Well, I think the way it was very nicely illustrated, in fact, in SR 1.5, a report in 2018. Basically we know, climate change, should be addressed using mitigation, which includes emission reduction and CDR. There is also, of course, adaptation, but we all know that, we could adapt only to, some amount of climate change. When the climate change is large, there is no way we can adapt to it. And, emission reduction, in general, mitigation has been really hard. So one instance where SRM, is in fact I would say, advocated or we talk about using it if in the future, let's say we exceed 1.5 degree for a brief period of time, let's say for a couple of decades, right? So these are scenarios that are called overshoot scenarios, where the temperature basically exceeds either 1.5 degree or 2 degree Paris temperature goals for a very brief, like couple of decades. So, can we use SRM for that very brief period while mitigation, is taking place? So in some sense, let me put it this way, very simply, SRM has been kind of, is suggested as a supplement to deep mitigation in overshoot scenarios. Yeah.
Great, thank you, Bala. We have, if I move on now, I think we have just a few minutes left of the Q&A. There is a question here from Joshua Sarnoff on what would international SRM or CDR governance look like, part of the UNFCCC, what kinds of controls, reporting, risk management? I'm going to defer that question, Joshua, if you don't mind, as this is about the physical science. We will be running further C2GLearns on the Working Group 2 and Working Group 3 reports, where, as I understand it, those kind of topics will be addressed in more detail once those reports are published, unless of course any of the speakers here would like to make a brief comment on that before we move on. Bala, yeah.
I'll just make one statement. In fact, just this week I read a paper where the proposal was to completely ban basically the proposal is to come out with non-use of solar geoengineering. So there are extremes. So right now, there are a lot of discussions, and but I won't comment more than that.
Great. Okay, thanks. And I should say, I'd point you to the C2G website as well, and you can learn a lot more about the governance situation with regards to these. We even have various evidence briefs on these topics as well. So if you want to learn a little bit more about the current situation in the research literature, then check out our website. In the remaining few minutes, I think I'd like to just turn to each of our speakers in turn and ask about, we've heard obviously the IPCC reports are a tremendous effort, and they're tremendously useful for decision makers and the policy making process to really understand the latest science. And they take a long time to produce, we know that, and they introduce we learn a lot from each one. And thank you for your time today and your presentations. I think I've certainly learned more that I didn't understand, and hopefully our viewers have too. But perhaps before we close the Q&A now, maybe each of you would like to say something about where the gaps are, some of the big gaps that you see perhaps in your specific domain that were flagged possibly in the report, particularly in relation to carbon dioxide removal or SRM. So what do we need to learn more about in future, possibly in successive reports? Mindful that, of course, there's subsequent reports coming out as part of the Sixth Assessment, but if I could phrase the question in a very broad terms like that and give you an opportunity just to mention anything you'd like on that. Could we start with, let's start with Kirsten.
Yeah, thanks. So with regard to CDR, I think we need to understand the climate effect of specific CDR methods a lot better. So so really to look at how the entire Earth system responds to those interventions, both in terms of this biophysical effect that I mentioned, but also effect on other greenhouse gas cycles, such as methane and nitrous oxide. And because these effects can be potentially significant. So yeah, so that's something we need to understand better. Also what some of the potential trade-offs and co-benefits are for other societal goals. And then something I'd like to point out is also there's quite a divide between, I think, the scientific community and the policy world. So in the science community, we people are aware of these effects, but actually at the scale of implementations where offset protocols are designed, there's very little awareness of that. So I would say on the non-science side, really attempts to bridge that science policy divide.
Okay, thanks, Kirsten. Joeri, would you like to go?
Yeah, in addition, I think from the physical science, there is a key research gap on understanding how these CDR or the carbon dioxide removal methods perform under a changing climate in a changing world. With environmental conditions, the land and the nature-based ones, with very different climatic conditions, and I think that is, and also with different disturbance patterns. So I think that is a key research direction.
Great, very good, thank you, Joeri. And Bala.
I think in a much bigger picture, I think I would say we need to understand the risk of climate change with and also without SRM, right? There is also risk to climate change, and then also risk with without SRM. So I think that needs to be understood in a very holistic manner. I'll just come to specifically, some recent developments where this relates to also knowledge gap, particularly in SAI research, right? I think what needs to be understood. I think recently there is a lot of emphasis on the aerosol microphysics, understanding aerosol microphysics. Particularly, it causes, for example, stratospheric warming. Now, this warming actually introduces, let's say, it actually reduces the effectiveness of SAI. It introduces water vapor into the stratosphere, which is another additional greenhouse gas, and it also basically disturbs the stratospheric dynamics. So that needs to be well understood if you do want to understand SAI. In addition, what are the effects of stratospheric SAI on stratospheric ozone, right? I think this is I think that's an area of a key active research right now. Yeah.
Okay, great. Thanks very much, Bala. And our time is up, ladies and gentlemen. So it remains only to say, so thanks very much to our speakers for today, and for you, the viewers, and for your great questions, and of course the team in the background helping make all this happen. I should say, do visit the website. You can find more information there. There's a dedicated briefing on the Working Group 1 report, and lots of other resources to find out more about this. We're simply trying to signpost. Obviously, C2G is impartial about all these approaches, and you can find more content on the website. So also, once the webinar closes, you'll see a survey that pops up. So we'd encourage you to feedback any comments or criticisms or compliments, willingly accepted, and that'll help us improve our subsequent events going forward. And do join us again later in the year when we'll repeat this C2GLearn for both the Working Group 2 and Working Group 3 reports as they come out. Thanks very much, and join us next time.